Welcome back to the Sedona Community Office Hour. So this is the office hour for February 2026. So first of all, some brief introduction about Apache Sedona. Sedona is the most popular open source cluster computing engine for geospatial data compute of any scale. And our website is at sedona.apache.org. And we also have our open source GitHub repository under Apache Software Foundation. We also have social media accounts. We have accounts on X and also account on LinkedIn. Be sure to follow us and get the latest news. Uh, so in the past few years, Sedona has grown significantly. And as you can see here, so there are lots of users of Sedona and they use Sedona in production from different industrial sectors, including logistics, finance, real estate, public sector, agriculture, and technologies. So the overall downloads of Sedona has exceeded 65 million. And the year-to-year growth in terms of downloads is over 200%. And if you look at our GitHub right now, so we have over 150 contributors. Sedona has a couple projects. So the main project of Sedona is actually for distributed compute. So it supports a couple different engines. For batch processing, it supports Apache Spark and Snowflake. For stream data processing, it supports Apache Flink. And recently, we also announced two sub-projects under Sedona, SedonaDB and SpatialBench. So SedonaDB is designed to be run as a single node processing engine. It is designed to handle small geospatial data. We also have SpatialBench, which is a benchmark that is used to analyze the performance of geospatial analytics query engine. And with all those components and projects in Sedona, Sedona now is able to make it easy to process geospatial dataset of any scale. Some quick overview about the Apache Sedona ecosystem. First of all, let's take a look at the distributed mode of Apache Sedona, which is the main project of Sedona. In this project, Apache Sedona has multiple layers. So the spatial query processing layer and the distributed spatial dataset layer, as well as distributed engine. So the spatial query processing layer provides different programming interface, including spatial SQL, Python, Scala, Java, and R. And it also equipped with a number of different spatial query algorithms. Given different queries, we also have a spatial query optimizer that can automatically choose the best query algorithm given the input data statistics. In the distributed spatial dataset layer, it has a couple different technologies to store the dataset in a distributed environment. First of all, it has spatial data partitioning, and it also has simple indices. It builds indices among different machines in the clusters. It also have spatial data serializer. And the Sedona can run on top of a number of different engines, Apache Spark, Flink, and Snowflake. By far, our support on Apache Spark is the most comprehensive one. So last year, in September, we announced a new sub project called SedonaDB. As you mentioned, SedonaDB is a single node processing engine for geospatial data. It treats geospatial data as a first-class citizen. It has columnar environment data sets. It also equipped with spatial query optimization, query processing, and the raster functions of SedonaDB also coming soon. So we have Sedona committer Dewey here today. So he can talk about the SedonaDB new features later on. And some quick start about Sedona. if you want to use Sedona Spark, so the easiest way to get started with that is to go to our Docker Hub account, which is also under Apache Software Foundation. You can pull the latest image of Sedona, which is 181. You can actually run this locally on your laptop. It will start a local Spark cluster with Sedona in that, and it has also a Jupyter notebook attached to that cluster. You will be able to start program in that notebook. It also has a Zeppelin notebook that allows you to create charts alongside with your code. So in addition to Sedona Spark, we also talked about SedonaDB multiple times. So SedonaDB is also very easy to start. If you want to start SedonaDB, you can directly do pip install Apache Sedona DB. And after that, you'll be able to start your Python shell and start to program. And the Sedona follows the 3-month release cadence. So this is about the Sedona main project, right? So SedonaDB is still working on its release cadence. Right now, we have seen so far for SedonaDB, it's also roughly about 3 months. So for the Sedona main project, we started to we have this 3 months release cadence. So in 2025, it has 3 release: 171, 172, 180. And in January this year, which is last month, so we released 181, which is the maintenance release. Maintenance release of 180. So the agenda here today, we're going to cover the following topics. So we're going to talk about the community growth of Apache Sedona in 2025, and we're going to also go through the new release of Sedona 181, which was released last month. We're going to go through the new feature of that, and after that, we're going to also talk about SpatialBench point zero, point one release, and also we're going to also talk about the Databricks blog post on Sedona performance recently. And finally, Sedona committer Dewey could also talk about the new release of SedonaDB, which was released December last year. So the Sedona community in 2025 has witnessed significant growth from multiple aspects. First of all, there are a couple new committers and contributors join the project. So we have a few new committers, Pranav, Peter, and Dewey. We also have a new PMC member, Flink. Thank you all for the contribution. And we also have more contributors participate across the year in 2025. So in 2025, we have 27 new contributors join the community. And in total, there are 46 people contributed to Sedona in 2025. Of course, that includes new contributors and the existing contributors. So in total, we have 155 contributors in the Sedona main repository. In the SedonaDB sub-project repository, we have 26 new contributors in 2025. And in SpatialBench, we have 8 new contributors in 2025. So those two are new projects, so they are still growing. And also the adoption of Sedona continue to grow. As I mentioned earlier, the total downloads of Sedona is now 65 millions, and the monthly downloads of Sedona is about 2 millions. And the GitHub commits activities increased from 1,500 in 2024 to 2,100 commits in 2025, which is significant growth. So speaking of Sedona 181, so there are a couple new features included in this release. Of course, there are a couple other bug fixes, given this is a maintenance release. But I'd like to focus a little bit on the new features that was released in 181. So 3 of them. First of all, we add a Sedona Flink SQL module. Also, we have a stack authentication support for both Python and Scala API. We also add a few new functions, new ST functions, are quite interesting to the project. So first of all, we recently added a new Sedona Flink module, Flink SQL module. So by that, now you'll be able to register Sedona Flink SQL module without Sedona context. So just like what we have currently in Sedona Spark, you don't have to actually use any Scala code to read a Scala Python code to register Sedona spatial SQL function in Flink. So before 181, so what you're going to do is that you're going to use a function called Sedona context.create to actually register Sedona spatial functions to Flink. But now with 181 release, you'll be able to write spatial SQL in Flink directly in pure SQL environment. As long as you put the jar, Sedona Flink jar in place, you'll be able to call load module Sedona to register. And you can also do a load module Sedona to unregister those functions. And after you register the functions, you'll be able to directly use those functions in spatial SQL. Oh, I saw there is a question in the chat. So it is actually about SedonaDB. So since I'm gonna continue my presentation, so Dewey, maybe you can answer those questions in the chat. Okay. I saw there is a question in the chat. Andrew, you raise your hand. So let me see. Do you want to talk? Dewey, it is actually the question is in the Q&A. It is about SedonaDB. You should be able to see that. Oh, okay. I guess I need to make you as a panelist. I believe now you should be able to see the Q&A. All right.
I still can't see him. You probably just have to you may have to read it to me because it might have happened before.
Oh, okay.
Or just repaste it in anything really.
I guess I need to make you a co-host. Then you should be able to see that.
Can't see anything.
Really?
Nope.
Okay.
I think it loads them as they come and
Okay, let me put in the chat. It
paste
is
it, ask
actually
it
about
again. Yeah.
yeah. Let me just type in the chat. Can I see the chat?
Oh yeah, totally. Yeah, GCS should work. I'll paste a link to the the URI syntax.
Cool. All right, so yeah, I'm gonna move on. Right, so do you can paste your link in the chat?
Oh yeah.
Cool. Let's move on. Another new features we have in mind one, as I mentioned before, is a stack authentication support. Couple release back, Sedona released support for stack catalog. That means you will be able to use Sedona stack data source to directly read raster data from stack catalog. So this stack data source allows you to this new stack data source to actually read directly from stack with authentication requirement. Some stack catalog, because they are private catalogs, you will need to have authentication in order to access those data. So and many of those stack services requires, for example, HTTP basic authentication, bearer tokens authentication, and also customer headers. Now, with this new release, you'll be able to add those So it's very simple code. And also our support, our stack client is also compatible in terms of API with PyStack client. So the code you use with PyStack, you'll be able to directly use them in Sedona Stack client. Another two interesting functions is the ST approximate middle axis and also straight skeleton. So those are very interesting functions. So let's take a look at the first function, ST approximate middle axis. So both functions are actually very useful when it comes to computational geometry requirement. In particular, it can be used to help you construct neural network from neural network inferenced from satellite imagery data. So in particular, the approximate middle axis, what it does is give a neural network inferred from the satellite images. So it tries to figure out the middle axis of that inference geometry polygons. So here is an example, right? So not sure if you guys can see this very clearly, but on the left, there are two neural networks, right? So those neural network has orange area. So those orange areas, they are actually polygons that are inferred from the original images. So those are very complex polygons. And what we actually need is out of those polygons, we actually want those neural network which are line segments. So what people usually do is that once you do machine learning inference, run a computer vision model on those, you're going to get polygons. But those polygons are very complex, have lots of vertices. Now you're going to run simplify functions. For example, ST simplify on those functions to get a simplified version of those polygons, like the chart, like the maps you see in the middle. Those are two versions. And after that, you're going to run ST middle axis, approximate middle axis on those polygons. This will be able to return you the actual neural network out of those polygons. So this is a very useful function, in particular when it comes to the this kind of situation. All right, let's move on. So another important project we mentioned before is SpatialBench. SpatialBench is a benchmark for accessing geospatial SQL analytics query performance. So SpatialBench has a couple components. We have a data model that talks about how data is, because when you do a benchmark, right, you need to have queries, you need to have data. So the data model in SpatialBench talks about how we design the data model in terms of data distribution, schema, all those data. It has a data generator that can be used to generate the data that follows the requirement in the data model. It also comes right now, there are 12 queries, comes 12 queries in total. It tries to challenge and test different components of a spatial database engine. So here is the result we have before. This is the result we conducted in September 2025. So we have SpatialBench scale factor 1 and scale factor 10. By the way, scale factor indicates the size of the input data. So usually scale factor 1 is sort of corresponding to 1 gig of data, and scale factor 10 is 10 times that, around 10 gig of data. So as you can see here, so suddenly we compare SedonaDB with DuckDB and GeoPandas, right? So SedonaDB has balanced performance across all queries and all scale factors, and in particular, it works pretty well on spatial drone. And we also made SedonaDB release, sorry, SpatialBench release last month. Now you'll be able to install SpatialBench DB through PyPy and Grid.io. The DB is what we mentioned before. It is a data generator that will be able to generate data that follows the requirement and standard data model in SpatialBench. Okay, so I'm gonna skip this. So recently, there is a Databricks blog post on Sedona performance. This blog post was released in, I believe, in December last year. So uh, it says you will see up to 17x plus performance compared to classic cluster with Apache Sedona installed. So they compare this with their own spatial SQL, right? So the truth is, so Databricks didn't speak to the cost of the result because their spatial SQL is around 2x more expensive than the original Spark. And also, this is not an apple to apple comparison. So we actually use SpatialBench to run this benchmark and compare Databricks Spatial SQL against open source Apache Sedona on Databricks Spark cluster. And we also compare with classic Databricks jobs, Databricks serverless SQL, and we normalize all the queries based on the dollar cost you spend on each query. And we use SpatialBench, and here is the result, right? So we conduct benchmark on SpatialBench scale factor 100 and scale factor 1,000. So those queries are very challenging, right? So as you can see here, there are two tables on the left. So there are lots of queries that cannot even be finished by Databricks serverless SQL. And in the query that both engine can finish, right? Some query Databricks is cheaper, but in many cases, Databricks is way more expensive than Apache Sedona, given Sedona is a free and open software that you can install on Databricks Spark or any Spark environment without any cost. And this blog post is, we also have this blog post published on Sedona website. So if you're interested, you can visit our blog post on Sedona GitHub, Sedona offshore website, and learn more details there. All right. Now we're going to talk about the new release of SedonaDB. So let's welcome Sedona committer Dewey to talk about his new SedonaDB release. Dewey, please take over.
Yeah. Sorry, I was realizing that when I typed that reply, I think I just typed it to Gia and Pranav, and I think that that was probably not who wanted to see. So Gabriel, I answered your question in the answered thing. I'm pretty new to the Zoom Zoom panel. But yeah, I'll share my screen real quick and talk about SedonaDB. Yeah, bring that down. So yeah, I spent a lot of time working on SedonaDB. There are lots of great contributors, and I spent a lot of time reviewing those. And yeah, and we're about to put together the next release of SedonaDB to 0.3. We have most of our blockers taken care of, and I'll chat about those in a second. But yeah, we'll just chat about some of the newish things and the things we're working on. So yeah, to get started, we're on pip, and this is it's a quick install command. And once you get going, you've got this SD thing that lets you, it's much like a Sedona context if you're coming from Sedona. Or if you're coming from DuckDB, it's like a connection. If you're coming from DuckDB or from GeoPandas, this is more like the GPD or like the GeoPandas module. And this is where you can do things where you start, create data frames and read files, um, and start typing SQL. So some of the things we started that we worked on in GeoParquet 2, sorry, GeoParquet 2.0 is coming too in SedonaDB 0.2. Is reading GDAL. And this is actually using the same thing that GeoPandas is using to read GDAL. Because SedonaDB runs on Arrow, and so does GDAL. We can read files, and I very nicely forgot to copy this particular example file in, but this can be a URL, and I'll just grab the URL straight there. One CRS example, Vermont. So there we go. Yeah, this can be a URL. This can be a zip file. And these things are all should be all supported. Yeah, nice state of Vermont there. Yeah, these can be zip files, and these can be URLs, or you can read using a glob. You can read, 40 flat GeoBuff files, and it will sort of read them all in for you and combine them all together. This is kind of the behavior that people are coming to expect with things like DuckDB and in Data Fusion with reading Parquet files, also with Sedona Spark, reading Parquet files. You sort of expect the ability to combine more than one of these things and query them all as if they were one table. And so now you can do that with GDAL data sources too. So that means flat GeoBuff, shapefile, GeoPackage, and any one of the dozens of files that GDAL has a driver for. Yeah, one of the cool things that we can do as part of this is Sedona DB is striving to be not just something that can read and write lots of different types of file types. It's sort of one of the only engines that has a developer base that can inject some of these spatial ideas inside the engine. And so we can be smart about executing queries in a way that it's tricky for other query engines to do because they just don't have the people to do it. So one of the things that we can do is flat GeoBuff is pretty famous. It's a cloud native format. So if you have a huge flat GeoBuff file and you only want to query a part of it, then you can do that. And in SedonaDB, that's usually like with a where clause here. And this is a 12 gigabyte file, yeah, sitting on the internet. And this is not going to download 12 gigabytes. It should, if everything is configured correctly, only download the part of it that it needs, which is pretty cool. Yeah, so we added GeoParquet 1.1 write support in the last version. And GeoParquet 1.1, which is the latest version of GeoParquet, added a mechanism to make sure that we can read as little of the GeoParquet file as is required. So this is the version that Overture is using. And Overture engineers were the people that pushed the changes in GeoParquet 1.1 to make this happen. This basically is what enables Overture to sit on statically hosted on S3, and it allows people to query only the parts of it that they need. And so if we take our flat GeoBuff file here, then you can just specify the version we write. And if you read that back in, you'll get the geometry bounding box column. And this bounding box column is what enables that write support to, or that partial read support to work. In the next version, and the version we're about to release, we should be able to read and write the latest version of Parquet, which means that you actually don't need this extra bounding box column and you still get all of the benefits of GeoParquet 1.1. Yeah, and this works. One of the cool things that you can do is you can now convert a whole whack of shape files or geopackage files or whatever you'd like, and you can write GeoParquet 1.1. And a super important part of that is being able to reduce the row group size and sort by the geometry column so that you can get nice tight row groups. So yeah, you can basically take any GDAL data source now. We're trying to be an excellent sort of Swiss Army knife of data formats so that it's very easy to do this kind of thing. Yeah, so now you can sort of take a random URL to a shapefile or something, and you can output nice GeoParquet. Anyway, that was pretty exciting for me anyway. Python UDFs, we provide a lot of functions, and I think we added dozens of functions in the last release, and we have dozens more coming. I think we're up to over 100 functions with full post-use compatibility. But if you don't have them, then you can also write a UDF. So this is using Shapely to buffer instead of SedonaDB to buffer. And I just fixed a bug in this, so yeah, this should in the next release this will be a bit faster. But yeah, in general, we can execute sort of arbitrary Python code within a SedonaDB pipeline if you have a very specific function that needs to do. You can also do this. There's a way to, I didn't show it here, but because it's been supported for a long time, but you can also just generate, have a Python generator that's spitting out batches to sort of as a workaround to read whatever kind of file you need to read. And finally, a few things that we're going to work on for the next release, which should be out in a few weeks. Hopefully 2 weeks, I guess. Yeah, so this is how you download the latest, sort of the preview version. That's what I'm running right now. I don't know about anybody else. I'm really excited about random geometry generation. I'm probably possibly the only person. But one of the things that I'm excited about this for is because I spend a lot of time testing this engine, like SedonaDB, and also other engines. And while I like to use realistic data as much as possible, sometimes you just need a million points. And because I run into that a lot, I'm really excited that I can do this, and I have nice autocomplete to do things like generate 10,000 points right off the bat. So if you want to generate 10,000 points, and then you can also send it to pandas, if you want, and that'll this is super useful for testing. It might be mostly useful for me, but I'm still excited about it. Something that gets Gia very excited is item level CRS. So in most of the examples, well, all the geometry columns that were supported in 0.2, you get the geometry support is at the type level. So it's like GeoPandas. GeoPandas, when you read in a file, or GDAL is the same thing. Parquet has the same idiom, where like when you read in a file, you have one CRS for everything. And so we store that at the type level because it's very efficient. We don't need to store it with every single value. If it's latitude and longitude, then SedonaDB knows this type is latitude and longitude, and all the errors that you get happen before any execution takes place. But sometimes when interfacing with other systems like Apache Sedona or the new Spark geotypes or PostGIS, you need the ability to do an item level CRS. This mess of CRS of SQL here is to generate a sample table. And so I'll show you that sample table. Whoops. We need the name of the view. So this is my sample table here. We sort of use this random geometry function to generate some random latitudes and longitudes. And here I calculated the UTM zone for all of them. So if you have a whole bunch of latitude and longitudes, that's great. But sometimes you need to do stuff that is not in latitude longitude space. And the example that I put together here is let's see, the example that I put together here, I need to paste from another window because I just came up with it. Oh yeah, there we go. So the example that I'm gonna do here is one of the examples where there's something that you need to do that is not in latitude longitude space anymore. And a lot of a strategy for dealing with that is moving it to UTM zones and then doing something and then translating it back. This is an example of a buffer, but the example that we came across recently is our CTO or no, our head of engineering was trying to do racetrack things, and he had racetrack all coordinates in meters, and he had the center of each racetrack in latitude and longitude. And that's just a really, really difficult problem to work around if you have only one CRS for an entire column. And this is global, these are all global data. So here's an example where we have our geometry column, and we can transform it into this UTM SRID. So we can basically take a vector of SRIDs at the column level and transform this geometry into it. And so now this geometry here also now has one CRS per row. So they're all in local coordinates. And then we can buffer that. And then we can translate it back. And if we do this, I think if we do the whole thing, 100,000 points, it takes like 6 seconds. And I think that's mostly the buffer operation. But yeah, you can start to do some of these stuff. And this gets to be very important when working with rasters because rasters are global. We have imagery from all over the place, and it doesn't make sense to have those pixels be in anything except a sort of local coordinate system, usually UTM. Anyway, I'm excited about that. This item CRS thing, I recently came up with a thing. Everybody put their water sampling locations in different UTM coordinates. And so now you can just read that in with SedonaDB. And as long as you have a way to express your CRS or UTM, sorry, your CRS or S or ID, then you can translate that back into one coordinate system, or you can go the other direction. You can explode it. Yeah, there's some more stuff coming. Reading Parquet files with the built-in types. That makes writing these cloud native data sets and reading these cloud native data sets a bit easier to do. We're gonna have new SD function docs with pictures. Very exciting for me. We have some performance improvements. Anything that had GEOS backed was between like 10 and 75% faster. We rewrote the WKP writer, or Peter did. And yeah, we've got some R data frame API things coming. A lot more functions. People just keep contributing them. It's amazing. And the big ticket item is that Kristen's been working on is the larger than memory spatial join. So you can sort of fearlessly join any size data set with any size data set, and SedonaDB should be able to finish it for you. Yeah, and some other things coming up in future releases, not this one. We've got a GPU-backed spatial join, which Liang has been working on. That can there's some very specific types of joins where that gets like way faster. We've got a point cloud reader and geography data type, which I'll be working on in the next release, which will basically make this type of thing where you have to transform into multiple UTM zones, make it so you don't have to do that. Just do the buffer and it will automatically know what to do. So yeah, thanks. These are all the contributors to 0.2. There's even more for 0.3. It's very exciting to be able to work with all these people on this project. And I'll paste a link to this notebook in the chat with some of these examples.
All right. Thank you, Louis. Great. So there are few questions in the Q&A. Well, I think
Let's
those. Go ahead.
Yeah, sure. I can type a few things. Read PyOGREO. That's not available in Sedona Spark, but Sedona Spark does have a shapefile reader and a GeoPackage reader built in, which is kind of necessary to get reasonable performance for what that's trying to do. I don't think flat GeoBuff support is available. And let's see. Geodatabases. Do you have geodatabase support in Sedona Spark, Geo?
I don't think so.
Okay.
I don't think so. We have GeoParquet, but we don't have GeoDatabases.
Yeah, so you'd have to go through GeoPandas for that probably for today. You have to read using PyOGREO into GeoPandas, or into straight into an arrow table would probably work. You might be able to skip pandas in a pinch. But yeah, you'd have to go through GeoPandas today probably. And yeah, if I'm not sure exactly what the F3 question is, and perhaps you can
Yeah.
clarify if I don't answer it properly, but
Yeah, I think that's about the. Actually, I think Sam has a question before, so I answered that. So I
okay.
think what he's asking is like, how can we load a large amount of raster data into Sedona Spark?
Right.
So, well, there's one challenge we have so far in Sedona Spark for raster data support. We know that when there are very large raster images, in particular, I'm talking about those images itself. Each image is like hundreds of megabytes large, or each image is like 1 gig large, right? So right now there is a limitation on Sedona raster to load those images. Sometimes it actually first it is very slow, and secondly, it sometimes explode the memory of the cluster. So we will be releasing a new features inside on a Spark raster that actually allows you to tell those rasters before you actually load the whole thing into memory of the cluster. Cool. Another question. Can we also work on satellite images, like directly fetching them through API and perform analysis on it? Do you have like a example of those kind of satellite image data, like a particular API that you are using? Okay, simple way. Okay, that's a good point. We haven't thought about that. Uh, hmm. But also, yeah, please feel free to create a ticket on Sedona repository, right? We're gonna take a look at that. We haven't thought about that actually. Not sure how that can be done exactly, given that you know many of those Sentinel-2 images, they are, I believe they are GeoTIFFs, right? I'm not sure if you can do streaming on GeoTIFFs. Mm, cool. All right. Uh, well, we are here. One final thing I want to share is so we have a Sedona annual book recently released. And right now, of course, you can order that on O'Reilly website. You can also order that the paper copy of this book on Amazon, right? But currently, Wearables is also offering a free copy of Sedona annual book, the ebook. So you can search the name of this book on Google and with Wearables after that. So you'll be able to download that on Wearables website with a free copy. So this book, as you see there, so Pavel, which is a PMC member of Sedona, Pavel, me, and Mo Sauer, we are all Sedona PMC members. So we wrote this book and talk about, in particular, this book focuses on how you can deal with large-scale geospatial data. Use Sedona, Sedona Spark, Sedona Flink, and I believe there is a small chapter also about SedonaDB. So if you're interested, be sure to get a copy of this book. Please drop that link here. Okay, let me see. Uh, okay. Put that in the chat. Okay. Yeah, so this is the link to get the free e-copy, ebook of this Sedona O'Reilly book. All right. So, all right. So, as we come to the end of this office hour, so I'd like to also always call for help for Sedona. So you can always contribute notebook examples to both Sedona, SedonaDB, SpatialBench, right? So this doesn't have to be really complicated examples, but very nice and the beautiful examples would be also really helpful. And you can also contribute to those websites to our repository to like contribute documentation of this. So if you see there is a typo, if you want to contribute an example to the API doc of Sedona, feel free to do so. You're more than welcome. And you can also participate in our release test. So we actually have voting process for each release of SedonaDB, SpatialBench, and also Sedona Spark. So if you're interested, you can actually participate in that, and you can help us verify signature and perform some basic correctness tests for each Sedona release. So this release voting process happens on Sedona mailing list. So if you're interested, you can subscribe to our mailing list. And occasionally, we also have live stream about Sedona success story. So if you're interested, you want to talk about how you use Apache Sedona, different sub-project of Sedona as well, and feel free to reach out to me. You can send me an email. My Apache email is here. You can also reach out to me on Sedona Discord. So if you haven't joined our Discord, so be sure to join our Discord. We have over 600 members there. And be sure to join us there and ask questions. And many Sedona PMC members and committers are on Sedona Discord.